Hello guys, welcome to my channel Civil Engineering with Shornu. Now our first topic is what are the type of supports. Now there are mainly three types of supports. One is hinge support, that is like that. There is a hinge and this portion is like that. There is a hinge and it is a member. This is a hinge support. Now second is a roller support. Now roller support means this also look like that, and it have also a hinge there, and it also a roller into its bottom. So it is known as roller support. Now third one is fixed support, that is like that. It is a fixed support. Now what are the type of reaction came into the supports? Now for hinge support, uh, what is reaction? If we apply any force into a body, the body gives some resistance, and as a result of resistance some return force is acting. This is known as reaction of supports. You have taken a beam. There is think that there is two supports. You are loaded the beam, externally loaded the beam. So for that load, the support want to resist the load. As a result, the support will also give some force in the opposite direction of the load. So this force is known as reaction of the supports. Now we came into it later. Now we can see the types of beams. Now there are many types of beam. We are came one by one. Now first, simply supported beam. It's a beam of one is hinge support and other one is roller support. One hinge support and one roller support make a simply supported beam. Okay. Now second one is cantilever. For cantilever, one end is fixed, that is like that, and other end is fully free. This type of beam is known as cantilever beam. Now next one is one end overhang, that is this is a simply supported beam. But this end is overhanging. Okay, that this end is overhanging, or this is a simply supported beam. Either right or left, any end, any one end is overhanging, then it is known as one end overhang beam. Now for both end overhang, how it's look like? Now for both end overhang, it's look like both ends are hanging. It is known as both end overhang. But why we are knowing these things, that different types of beam? Because depend upon the type of beam, our analysis is depend, the reaction calculation is dependent the beam upon the beam, because if the different type of support gives different type of reactions. We came into it later. Now last one is fixed beam. Now for fixed beam, both ends are fixed. Okay, both ends are fixed. Now last but not the least, that is continuous beam. That is, for continuous beam, the supports are continuous, like this, like this, like this. This is a continuous type of beam. Now we are came to the previous thing, that there are three types of load. One is vertical, one is horizontal, and other one is moment. Okay, so there are three types of load, and also there are three types of reaction. For vertical load, the vertical reaction. For horizontal load apply, for resisting horizontal load, the support will give horizontal reaction. For resisting moment, the support will give the moment, resisting moment. Now for hinge support, there are two reactions. One is vertical, because the vertical end is fixed. If you applied a load there applied a load, the thing will not move. Okay, it resists the load, so it will give some vertical reaction. Also, for if we give some load in horizontal direction into the member, okay, now the support will also don't move, not move in horizontal direction, so it will also resist the load, try to resist, so it will give a horizontal reaction. So one is reaction we are denoting by R, and for horizontal, for vertical RV, and for horizontal RH. Now third one is moment. If we give a moment, so for a moment, for this hinge, the member will rotate, so there is no resistance about the moment, so there is no reaction about the moment. It's clear. Now we are came to the roller support. Next one for roller support. For roller support. Now for roller support, if we give a load in vertical direction, the support will not move in vertical direction, fixed about it vertical direction, so it will give a reaction in vertical direction, that is known as RV. But for the roller below the support, the roller is moved into horizontal direction. So if we are providing a horizontal load or give a horizontal load, it will not give any type of horizontal reaction, and for hinge, if we apply, will not resist the moment, because the member is free to move. So for roller support, there are only one reaction, sorry guys, that is reaction in vertical direction, and for hinge, two reaction, one is in horizontal and other one is in vertical direction. For fixed support, there are three types of reaction. This is fixed, this end is fixed. So if we applied a load in vertical direction, it will not move in vertical direction or able to free to move in vertical direction. So it is resist the load in vertical direction and give a reaction in vertical direction, which is known as RV. And now if we applied a load in horizontal direction, it will also don't free to move in horizontal direction, so it will give also a reaction in horizontal direction. And in this case, if we applied a moment into the member, then it is fixed, so it is not free to move for rotation, so it resists the moment. So in the fixed support there is also moment which will resist the external moment, that is M. So for fixed support there are three types of reaction, three reactions. One in horizontal, one in vertical, and one is for moment. So three reaction, one in horizontal direction, one is vertical direction, and one is for moment. Now this is clear. Now we are going to the next part, that is types of loads. Types of loads. Now types of load, there are mainly three types of load. One is concentrated or point load, that is point load acting on a member. This is point load P, acting on a point, specific point. Okay. Now for uniformly distributed load, or it is known as UDL, the load is distributed uniformly over the entire length or a specified length of the member. In entire length or specified length, that is we are taking for entire length, it is denoted like that. This is UDL. UDL or uniformly distributed load. It is given for load per unit area, load per unit length, load per unit length. Load is W per unit length. Okay. And the concentrated load is only load, that is P. Now for uniformly varying load, it is look like that. It is look like that. It can be many type, like W per unit length. Okay. It can be that is the intensity at the, it's like a triangle or a trapezium. Like at the base of the triangle the intensity of the load is maximum, if you think it like a triangle. And uh, going to the head of the triangle, the intensity of the load is going to decrease. It is also can be like that, like that, that the intensity of the load is maximum at there and the loads are decreased in both side. It can also be like that. uh, it can also be like that. We are looking for some, it's it can be also like that, that at the end, at the support, both supports, there are some intensity of loads. Okay, that this is W per unit length. So these are the type of loads, that one is concentrated, other one is uniform, and one is uniformly varying load. Now in next we are looking for the available equation of equilibrium, or you can say it the universal equations for equilibrium if the body is at rest. Okay, now there are three type of equation, that is summation of H equals to 0, that is all the horizontal force acting on that body, summation of all horizontal force equals to 0. Now second one is summation of V equals to 0, that means all the vertical force which are acting on the body is equals to 0. The summation of all the vertical forces are equals to 0. And the third one is summation of M. M stands for moment. The summation of moment equals to 0. That for every load it will create a moment, and these all summation of all moment are equals to 0. These three equations are available equation of equilibrium or universal equations to calculate the reactions of a body, or calculate now the very important thing, that what is a moment of a force. Moment of a force, now first we read the definition, then explain it. First, moment of a force about a point is the product of the force and the perpendicular distance of a point from the line of action of the force. It means if this is a body and a horizontal force is acting on it P, and we are want to taking a moment about this point, we want to know the moment about this point A, and the load is acting at a point O, then this perpendicular distance between the point and the load means it became 90 degree. Okay, now the moment equals to force means P into product of force and its perpendicular distance, means in this case AO. This is very simple. This is moment. Now we are come to the main thing, that is reaction calculation of a simply supported beam loaded with point load. Now we are taking any simply supported beam of any length, that range, this is roller support, a load, a load 10 Newton is acting on it. So how to calculate reaction of the support? Now at first step, we have to consider some sign conventions, that is sign conventions, that is for horizontal load, for horizontal force, left to right is positive and right to left is negative. These are very important for your calculation. Your calculation is mainly dependent upon how you are taking the sign conventions, or your calculation is fully dependent on it. If you take correct sign conventions, your calculation will be correct. Now second, for vertical force, down to upward is positive and upward to downward is negative. We are taking it. Generally this is taken. And for moment, we are taking anti-clockwise moment. Anti-clockwise. This is anti-clockwise. Against the clock is positive and clockwise is negative. You can also change, in some books there are clockwise is positive and anti-clockwise is negative. Don't worry about it. You have to properly take the convention. If you take the clockwise direction is positive, then you have to take the anti-clockwise is negative. Then your calculation will be correct. If you are taking both the anti-clockwise and clockwise in positive, or both the anti-clockwise and clockwise in negative, then your calculation will not be correct. Now for this beam, we are making the beam this side. We are done with our first step, that is sign convention. So our next step number 2, is reaction calculation. For reaction calculation, the equation will help us. Which equation? The universal equation. That means the available equation of equilibrium, that is summation of h equals to 0, summation of v equals to 0, summation of m equals to 0. Now we can make the beam in this side. It will help us for calculation. This is the beam. This is 10 Newton load. This is the distance of load from the support, that is 5 meter, and the distance between two support is 10 meter. Now name the supports A and B, and the point load is acting on C. Now we have to take the summation of h equals to 0, summation of v equals to 0, summation of m equals to 0. Now first, summation of h equals to 0, but there is no horizontal force is acting. Now first we see that for hinge support there are two reactions. One is RA, which is acting vertically, and one is HA, which is acting horizontally. But for roller support there is only one reaction, acting, that is RB, only in vertical direction, because I explained it before why there is one reaction only. Now for horizontal, there is no horizontal force, so there is no horizontal reaction. Now second, for main thing, that is summation of V equals to 0. That means summation of all vertical force acting on the beam is equals to 0. Now which vertical forces are acting into the beam? That is first is this RA acting, then in downward direction this force acting 10 Newton, and third the reaction RB acting in upward direction. Now we are taking sign convention that upward for vertical force in upward direction all the forces are taken positive, and in downward direction all the forces are taken negative. Now for calculation, first we are came from point A, where go from point A from first point. So there is a vertical reaction and it is in upward direction, so it is positive, so plus RA. Then come to the point C, the load is acting in downward direction, we are taking downward is negative, so minus 10. And the last thing, that is the at point B there is also a reaction that is acting in upward direction, that is RB. This summation of all vertical forces, no other vertical forces are acting on the beam, so this all equals to 0. Now for simplification we can make it as RA plus RB equals to 10. Now the third equation, that is summation of M equals to 0, that is all moment equals to 0. Now we have to take moment from any unknown point, because we have to eliminate one unknown for our calculation purpose. There are two unknowns, so we can take the moment, that is summation of M A equals to 0 at A or at B. Now summation of M A equals to 0. Now if we are standing at that point A, okay, so now which force can give moment about that point? First is 10 Newton. What is moment? Force into its perpendicular distance from that point. So from A point, this 10 kilonewton is acting in downward direction. So take your hand like this, like a compass. One point in the point from which you are taking the moment, and one point at 4 in which direction force is acting, and rotate it. So what is the direction? It is clockwise direction. So in clockwise direction we are taking the moment as negative. So now force into force, that is 10 Newton, into its perpendicular from distance from A is 5 meter, that is into 5, and whole thing is in clockwise, we are taking the clockwise as negative, so minus. Now the last one moment is there, that is for force RB. Now take your hand like this and rotate your other finger into the direction of force is acting, in which direction the force is acting, so it will make a anti-clockwise direction moment. So we are taking the anti-clockwise moment as positive in sign convention, so plus RB into its distance from this support A is 10 meter into 10. So these all the moments, summation of moment equals to 0. Now minus 10 into 5 is 15 plus RB into 10 equals to 0. So RB into 10 equals to 50, RB equals to 5. So we get that RB equals to 5. Now there is one reaction, that summation of V equals to 0, where written the reaction, the equation as equation 1. We are putting the value of RB in the equation 1 we get. So Ra plus, in the place of Rb we are putting 5 equals to 10. Now Ra equals to 10 minus 5 equals to 5. All are in newtons, so 5 Newton, 5 Newton. We will get Ra equals to Rb equals to 5 Newton, because Ra and Rb both the values are same. So thank you for watching this video. Hope this video help you. Mainly this video is for first year students of diploma. There is a subject called civil engineering, called engineering mechanics. So these small reaction calculation is there, types of supports, types of loads are there. It will help you in your studies. So thank you. This is in for today.